Welcome back, everybody. Continuing chapter 12 on climate and climate change. And this is going to be section 7, talking about can we predict how climate change is going to be taking place, and what kind of patterns can we look at to be able to predict that accurately. All right, well, there's this philosopher in the early 1900s named, named George Santayana. And he had a lot of kind of famous or sayings that became famous, and one of those goes like this: those that cannot remember the past are condemned to repeat it. All right, or some people say those who don't study history are doomed to repeat it, something like that. What that means is if you don't study things that have happened in the past, you're going to make the same mistakes that people in the past made. So the question remains, are human history cycles, are they actually going to repeat? So are we going to have an area like right now of global warming, and then is human history going to cause global cooling later on? Or is this something that is just going to continue to accelerate? We do know that natural processes continue to repeat, but does human history do that? Well, that's why we need to study our history to figure out if the effects that humans have on the environment is going to actually repeat. It's true that there was a period during the Middle Ages between 950 and 1250 where Earth was warmer than usual. All right, and there are some lessons we can learn from that event. One thing we found, that especially in Europe, was that culture and activity, as far as population and other cultural things, really enjoyed some major growth because it was warmer than usual. It also meant that the Vikings were able to experience and settle Greenland. Europeans were able to go to China, all because of it being warmer than usual. If it was a lot colder, then they would not have had the ability to travel these long distances and make these kinds of discoveries and settlements. On the negative side, many places were hurt by long, persistent droughts, famines, and the inability to grow to grow food was a result of this medieval warm period right here. So we should be able to predict, if this continues to take place, some of these events happening on our Earth in our time period. And so that's why we're worried about the repeat of these persistent droughts, because that could result in a major decline in the availability of food. All right. On the other side of that, we had what was called the Little Ice Age. This was between the 1400s and the 1700s, but that followed the medieval warm period. And so this was kind of an opposite side of that coin, where everything was cooler than usual. You had a lot more wet periods in Europe, a lot more storms and extremes of hot and cold in Europe. It also meant that places like Greenland were more snowed in, you might say, and they had to be abandoned because there was less bare ground to be able to settle. So these were some results of this Little Ice Age, which was an abnormally cooler time in Earth's history, and these are some of the effects that people on Earth experienced. Now, you may remember the term uniformitarianism back at the beginning of this chapter, where we take patterns and we assume them to be true and try to apply them to all of history. Well, we can try to do that, but it's going to be difficult because we don't have direct temperature data from all these ancient times. We have, you might call, say, a paleoproxy data, that is, was it generally warm or was it generally cold, but we don't have exact temperature data. So it's very difficult to reconstruct temperature data from the mid-19th century, that is the 1800s. We're even less confident about the medieval warm period in temperature reconstruction. So it's difficult to predict future climate change by applying uniformitarianism. So instead of trying to figure out what kind of, might say, natural climate patterns are causing global warming, the better question might be to ask, what's actually causing, I'm just keep moving that around again, what's causing the rapid climate change over the past, say, 100 years that could be a result of human results, that is, or human effects. Not anything that has necessarily happened naturally, but something that humans actually have control over. So we do know that greenhouse gases, extra greenhouse gases in the atmosphere, are the primary, or one of the primary culprits for causing the atmosphere to warm up and climate change to take place. So as a result, reducing those gases is our biggest goal right here. whether it's carbon dioxide, whether it's methane, all these gases, we have some control over how much of those we put into the atmosphere. So what we can do is we can look at the past and see what changes have occurred, which is why we're told we need to study the past to be able to anticipate what's happening in the future, and ask ourselves, all right, what kinds of systems are being affected by climate change? The climate itself, all right, storms, sea level, biological, economic, all these things are being affected, and that should help us predict what's going to happen in the future. So there have been international agreements made with regards to climate change, climate change, but with regards to greenhouse gases in the atmosphere. And in 1997, in Kyoto, Japan, the United Nations met and formed an international agreement to reduce emissions. That is, all countries said, all right, we're gonna make laws so that certain emissions are reduced, like from cars and factories and stuff. Interestingly enough, the United States has not come on board with that agreement quite just yet. It's really been Europe that has been the main front runners, kind of spearheading the reduction of emissions. And ironically, it's the United States that's one of the biggest producers of those greenhouse gases. And so if the United States is not on board with this, then it may be very difficult for just Europe to reduce the emissions that are put into everybody's atmosphere. So people are back and forth as to whether temperature increase due to emissions is accelerating or whether it's kind of lower than usual. But I think that's why maybe the United States hasn't quite come on board quite just yet, because nobody has really agreed. There's always been some sort of skeptic as to how bad the threat really is. So if you put enough doubt in the minds of lawmakers, they won't come on board with agreements like this, and so that could be the position that the United States is in. If we do look at things from the past, that is like a paleoproxy record, that is geological samples and tree rings, and look at the concentrations of carbon dioxide in old compounds and old atoms and molecules from ancient fossils and other materials. They do suggest, all right, that what upper estimates mean right here is that they suggest that it could be even worse than we realize it is. All right, it's not improbable that the climate change right now is a lot worse than it definitely would have been if we had been putting these emissions into the air. And another part of the problem is the fact that even if tomorrow, if we scaled back all of our emissions, it would take possibly decades or maybe even hundreds of years for the climate to restabilize. So we talked about the stabilization time and how long it takes for the climate to adapt. Well, even if we stopped right now, even if we stopped 10 years ago, it would still take a long time for the climate to kind of reestablish an equilibrium. So that's another problem that we're dealing with. Okay, so let's say that for 100 years we cranked out a lot of CO2, all right? And then after 100 years, we realized, oh, this is a bad idea, we should stop. If we stopped, then that means it would take another, I don't know, say 200 years for everything to kind of like balance back out. All right, but look at it, if you take longer and longer until you cut back on your CO2, what that means is it'll take longer and longer for the atmosphere or the environment, the climate, to readjust. So there really is a major lag time to the climate restabilizing to the new reality of having extra carbon dioxide in it. Well, what can we do to cut down on some of these emissions? Well, fossil fuel burning power plants like that burn coal and that burn maybe natural gas and stuff. The way we engineer that can possibly remove some of the carbon dioxide that would normally be pumped into the atmosphere. Natural gas is a good fossil fuel that puts less carbon and carbon dioxide into the atmosphere as well. So using cleaner types of fuel, it may cost more, maybe a little more expensive, but you're actually preserving the environment. Certainly conserving energy, so we're less dependent on fossil fuels. If that light doesn't need to be on, then why are you leaving it on? It's just sucking extra energy that has to be created by burning fossil fuels. So just conserve energy. That'll cut down on our use of fossil fuels. Also, alternative energy sources. We're using more and more solar right now. Hydropower. Of course, we talked about hydroelectric power, and that has its own problems as well. But it certainly doesn't put any carbon dioxide into the atmosphere. We also have nuclear power as well. All these are alternative energy sources that are alternatives to burning fossil fuels to produce energy. The good thing about trees, well, there's a lot of good things about trees, but the good thing about trees is the fact that trees actually, many people say they breathe in carbon dioxide. They actually don't breathe in carbon dioxide, they actually eat it. The substance of trees, the actual matter of trees, really comes from carbon dioxide that they take in through their leaves. And so the more trees, the more forests we have, the more that carbon can be stored in a form that doesn't hurt the atmosphere or that doesn't cause the atmosphere to warm up. So if we can store carbon in places where it doesn't cause global warming, that's a benefit as well. So store it in the soil, store it in forests, store it in rocks beneath the earth. Get that carbon out of the atmosphere and get it into solid places where it doesn't hurt the Earth's environment. You can look at this real quick. This is simply a comparison of how much carbon is emitted by various different fossil fuels. Of course, natural gas is one of the cleaner ones that doesn't put as much carbon dioxide into the atmosphere. Now, there is one big-time threat that is like a natural disaster that could come about as a result of this, and we call this abrupt climate change. And that is maybe over the course of a decade or two, large-scale change in the global climate system. All right, so not just happening gradually, but happening on a very, very large, very quick scale, maybe over the course of half of somebody's lifetime. And that could be the result of, or that could result in sea level changing very, very rapidly, flooding coastal areas, droughts and floods, and producing difficulties with generating food. Atlantic Ocean circulation causing to be colder where it normally isn't and warmer where it normally isn't. This is a problem too. As more permafrost, that's not a very good color, as more glacial ice melts, more Arctic soil is released, and that can actually start decaying and decomposing. And as it does, it releases methane into the atmosphere. So all these things can really have a large-scale effects on people in a short period of time. And we call this abrupt climate change. So even though we need a little more information about this, the good news is that we think that abrupt climate change is not likely in the next 100 years or so. Which should take care of us, but we need to worry about future generations. All right? The main things that are going to happen are sea level rise, which we know is happening right now, and also droughts in areas close to the equator. All right? But even so, the predictions about abrupt climate change we're not absolutely certain on. We just need more data to understand, data about the past to understand the predictions about the future. Okay, so let's take all of this that we know about climate and climate change and apply it to Tuvalu. This was our case study. This is the very low-lying islands in the South Pacific that are being encroached upon by the ocean, the sea level rise. Part of the problem that Tuvalu faces is that as sea level rises, there's a certain amount of time before the international community will recognize that that is rising. And unfortunately, that delay means that it could rise to a point where it's too late when we finally do something about it. There are short-term seasonal effects of changing winds and El Nino and causing sea level to rise. And so there's enough doubt in some people's minds that Tuvalu is being encroached upon by the ocean that the international community is not as fast at responding to it as maybe they should be. Another difficulty that Tuvalu has is the fact that, remember, they are made not necessarily from solid ground, but they're actually made from coral reefs. So say you have like a donut-shaped island right here, all right? Well, as the ocean level rises up, erosion is really going to start to threaten the stability of that island. Remember, it's not solid rock, it's actually kind of coral that they're built upon. So the ocean can have a big effect on that. So these atolls, what are really what Tuvalu, the island country, is made up of, is really directly related to the ocean. And so the relationship between the ocean and Tuvalu, you really cannot separate those. You probably know that tides take place, and this should say not high tide, but high tide. Tides take place because of the Earth's interaction with the moon. The gravity from the moon causes tides to be higher. But especially during high tide, or they call them the king tides in Tuvalu, flooding becomes a real problem. Not only does it come in from the coast, but water also bubbles up from the ground. Remember, these islands are made up of coral, very porous, not very solid at all. Low-lying areas definitely get flooded, and also water, drinkable, or that's what potable means, potable or fresh or clean or drinkable water is very unavailable because of all this salt water encroaching up on the land of Tuvalu. Good example, this was in 2006. The high tides and the sea level maxed out about 3.4 meters above the sea level, where the most elevation, much of the elevation, the average elevation, was only 2 meters. So large majority of those islands were flooded back in 2006. Lots of flooding. Right now, it even happens even more often than it did previously, and so a lot of plants were damaged because salt water, or plants which rely on fresh water, was contaminated by salt water that came in from the ocean. All right, so not only do plants need fresh water, but humans do too. So both sides of that were affected by the fresh water being affected and contaminated by the salt water. All right, imagine your neighborhood looking like this. All right, this is your backyard or your front yard, and you're just hanging out in your front yard, just floating in water. This is reality as the people from Tuvalu have come to accept it, and now they have to either mitigate that or do something about it. In many cases, people move away from Tuvalu because of all this flooding. Now, one of the good things about coral, as porous as it is that it does tend to cement itself together. Coral is made from limestone, all right, or calcium carbonate, and it can tend to cement together and become difficult to break apart. So what that does is it actually kind of cuts down on erosion from waves, which is good. Coral, being living things, tends to build itself up, so the shoreline has been building rather than eroding. However, as we mentioned before, the water doesn't necessarily just come in from the ocean, from the coastline, but it also bubbles up from the ground as well. And that's why we look at atolls, and as beautiful and as wonderful as a place like Tuvalu is, it may not be a very good place for people because they're not very high above sea level. There's going to be some time in the future where the islands, regardless of what they're made up from, will be overtopped with ocean water and just become drowned entirely. And as we move forward, the surfaces will become more available to waves to the point where they're eroded to the point where people can't even live there anymore. So atolls, as much as people love their home right there, they may not be a very good place to live because of how unstable the ground is. So here's a picture of some of that reef rubble that cements itself together that actually prevents the erosion of the shoreline. It's hard stuff. It's not like sand. Sand can get washed away real easily. But this is reef rubble, cemented together corals over time that provides kind of a buffer to wave erosion. Even so, the truth remains that people in Tuvalu may have to accept the reality at some point that they'll have to migrate somewhere else, either to New Zealand or to other islands, because there's only a certain amount that you can adapt to these changes in your environment. They may need to migrate to higher places on the island, which there aren't very many high places on the island. Like I mentioned before, some have already left the country and gone to places like New Zealand and other nearby islands. Can we build things to defend against the ocean? Sure, we can build sea walls and stuff and plant mangrove trees. What they do is they prevent, they kind of act as a buffer against sea waves as well. Salt-resistant crops that are able to withstand a little bit of salt water, and more storage of rainwater so people have fresh water to drink are all good things that we can do. But the question is, can we really do this to the point where Tuvalu can remain livable permanently? Or are we going to have to reach the sad reality at some point where Tuvalu may have to be abandoned? That still remains to be seen, but right now is the time to do something about that. So that's our Chapter 12 notes on climate and climate change, especially dealing with Tuvalu and our friends in the South Pacific. And I thank you for following along and listening. If you do have any questions, please make sure you come see me. But in the meantime, I'll thank you for watching, and I'll see you on the next one.